In this next example for section 5.3, we're going to be calculating standard deviation. And in this, I have included two students, Tim and Mary, and their 5-unit test so far in Math 2201. We'll look at their mean, the standard deviation, and along with that, there are a couple questions that we would like to answer. First, whose marks are more dispersed? Now, we mentioned dispersion back in section 5.1, where we had looked at that time at the range. And again, the range, remember, is if you subtract the highest score from the lowest score, and that will give you one measure of dispersion. Here, we're going to use standard deviation as another measure. So we want to determine how does this mean that we calculate, or dispersion, relate to standard deviation. If the data is clustered around the mean, how does this affect the standard deviation? And last, who is more consistent in their test marks? Now, to help us to do this, we're going to be using technology. So first, we're going to be using the Texas Instrument 83 calculator. And as I've mentioned in class, you can download the emulator for the TI-83 online. And that's what I'll be using today. You can also use Excel, a Microsoft Office program, or any other spreadsheet program. Google Docs also contains a spreadsheet, which I'll show you in class as well, and they pretty well all work the same. And if you want, you can use an internet application. There are also apps you can use for mobile phones, but again, here I'm going to restrict it down to these three. Alright, now I've loaded up the Texas Instrument emulator. So turn on the calculator, and I'll start back at the home screen. First, I want to enter my test scores as a list. So I push the Stat button, and I want to edit the list. So number 1. And I'm going to put in my test scores for both Tim and Mary. So those are Tim's scores. Now I'll insert Mary's scores. Now, to calculate the mean and standard deviation, I'm going to draw your attention back to the symbols we had mentioned last class. Remember that the mean is referred to as x bar, and sigma is our standard deviation. And the standard deviation we're calculating, it's going to be for population. So, in other words, we're not going to be taking a sample, we're going to include everyone. So population would involve all the numbers in a data set. A sample would be including only a selected or random number of samples. So if I want to look at a sample within the school, I could pick a grade or a random number of students. Population would refer to all the students in the school. Okay, so back to our calculator. Push Stat, and it's going to be calculate. And one variable statistics. As for my L1 list, so I find that the mean is 70, and there's several other pieces of data. Remember the summation sign I mentioned last class? Summation will be adding up all the scores. This is the total of all the scores there if I added them together. I'm going to ignore these two scores here. What I want here is sigma. So 7.07. So our mean is 70, and the deviation is 7.07. So we could count on average that Tim is that this is his mean, and that on any given test he could be 7 marks lower than this mean, or it could be 7 marks higher. So he could range from 63 up to 77, which is what we would typically expect. Now for Mary, okay, back to our calculator. And stat. And I'm going to go to calculate. And Mary was in the second list, so it's still one variable statistic, 1. And she was an L2. Her average is 70. Totals of her scores were 350. But her standard deviation was 6.36 if I ran. If I look only, say, at the ran to the nearest mark, she could range from 64 up to 76. Now we finished that using the Texas Instrument. And next we're going to focus on using Excel. So I already have Excel loaded. I've entered in Tim's marks here. And at this point I'm only going to use Tim's scores, since we should get the same thing back. So after we've entered in all of his test marks, I go to Formulas. Here you see Auto Sum. Well, that's the last formula that's there. I don't want that one. I'm going to go down to More Functions. And notice that before I done that, I highlighted this cell here. I clicked in there. Now, in case this category doesn't come up, just to show you, I'm going to go to Statistical Formulas. We'll go down and look, or you could type in what you're looking for. I can go down to Standard Deviation. And you can see there's several different standard deviations here. We're going to use this one here, and it refers to using populations. So it's asked me to pick the range of scores. So my range of scores are here. And so I highlight from one cell over to the next. And it tells me that the result I get back is 7.07, which is what I had gotten, and highlights it here. And I gotten that here. So I could do that for Mary, but again, I'm going to get the same result. Okay, at this point now we've calculated our standard deviation using the Texas Instrument. We've used Excel, and now we're going to focus on using an internet application for that. So to do that, I went to Google and just done a search for calculating standard deviation online. And here's some previous results that were there. What I'm asked to do is just enter in my scores that I have. So scores were 60, 65, 70, 75, and 80. And noting that I have to keep them separated by a comma, I hit calculate. Well, I had previously done these scores. So my standard deviation, and again, there's two standard deviations that show. The one that we want is in the population standard deviation. So 7.07, which is what we had gotten before. Now if I just try that for Mary's scores, 60, 69, 70, 71, and 80. And calculate. Again, I get the same standard deviation, population standard deviation that I had for Mary. And this little program here also gives me the total number of scores I had and the mean. Okay, so that's calculating standard deviation for each of the test scores. So whose marks were more dispersed? Well, we find that Tim had a bigger dispersion in his marks. He went from 63 to 77. Mary had a smaller dispersion. So Tim had a larger dispersion in his marks. So Tim had larger dispersion, sorry about that, in his marks. And how does this relate now to standard deviation? The larger your standard deviation, the more dispersed your marks are going to be from the mean. So if we look at Mary, again, the same mean as Tim. She deviated less on her test scores from the mean, and her dispersion was not as great as Tim's. So who is more consistent? Mary is more consistent. So key idea out of this, big idea. So what you're looking at is more dispersion for a greater standard deviation. There. So the smaller your standard deviation, the more consistent your marks should turn out. The closer they're going to be closer together to the mean. And two questions to think about on top of these in class is that could your standard deviation ever be 0? And what does that mean if it is 0? And could your standard deviation be negative?